In less than a year, we have grown to see six-figure revenue per month on Wix. Having an amazing website with Wix and having direct-to-consumer tools in place was at the core of our business. We are lucky to have a ton of orders, so we have outgrown fulfilling orders ourselves. We've sold out of our huge collections, thousands and thousands of pieces of inventory. Having an amazing website with Wix and having direct-to-consumer tools in place was at the core of our business. We are lucky to have a ton of orders, so we have outgrown fulfilling orders ourselves. We've sold out of our huge collections, thousands and thousands of pieces of inventory.
Hi guys, welcome to Competitive Programming with CodeChef. Before we begin, you guys know the usual drill. If you can hear me, see me and see my screen, please drop a thumbs up in the chat section. Okay, so alright, thank you guys. So hi guys, I'm Rohit. For those of you who don't know me, I am a final year undergraduate student at Jadavpur University. I I was a former intern at Amazon this year, and a few days ago, I have started a course over here, a micro course on hashing. Today is the final class of that course. In the first class, we had explored the theoretical details of hashing. We have seen in details what is hashing, why do we need it, what are the various parameters which influences the performance of a hash table, what are the applications of a hash table, the popular applications being the hash table or the hash map. So in the next class, we broke the ice with by solving some very basic questions on hashing. The questions we started with the most basic question, and we slowly increased the difficulty level. We also learned a little bit about prefix some data structures. In this lesson, we are going to take up a little intermediate level problems on hashing. We are going to learn a few concepts, and then we are going to apply those concepts to some really challenging questions, guys. Okay, so before we begin, I just wanted to recap some of the concepts which we have gained so far. Okay, so uh, so basically, these are some of the things which we have learned over the last two lessons. So I just wanted to do a brief recap because we will be needing some of these concepts today. So the first thing is that hashing helps us solve a lot of issues that are present in a direct addressing technique. So in the first lesson, we saw that we have a way to access, delete, and add elements in O of one time, and that was using a direct addressing, and that's known as the direct addressing technique. But that technique created a lot of issues. That technique had a lot of downsides or shortcomings, you might say. It wasted a lot of space. That approach was limited only to integers. So these are some of the issues which hashing tackled with great ease. The hashing was a magical way of solving all of those issues. The second thing which we covered was that two or more keys producing the same hash value is referred to as a collision. So we found that the hash function, which is the hash function, which is a mathematical function, it doesn't provide us with unique values each time. So sometimes a bunch of keys may produce the same value, and that thing is known as a collision. And we discussed that a collision is a very terrible thing, guys. From a hash table point of view, collision increases our search time. from a general point of view, collisions are are extremely bad things. Like a hacker can use a collision to directly get into your system. So we must try to avoid a collision as much as we can. The third thing which we learned was that a hash function can be used to convert a string to an integer. So basically, so what we saw was that we have, if we have some key, we passed it through a function f of x, and then we placed this value to some table. So we had some table, and we placed this value x in at some point in this table. So this was my key. This is my hash function, and over here this value is my hash value. That is what we saw in the first class. Now, another thing which we came to realize is that this thing can be an integer, can be a decimal number, can be a string, as long as we are able to write a proper mathematical function which gives us an integer output, we are able to use this in our hash table. So as long as we can write a proper mathematical function which will take in a key and convert it into a fixed size integer, this integer needs to be in a fixed size, we can place this key in our hash table. So this is our hash table. So if you revisit this point, a hash function can be used to convert a string to an integer. In the first class, we only saw a hashing with respect to integers. We haven't seen any hashing with respect to decimals or string till now. Today's class is going to be particularly based on this data type. We are going to see a lot about string hashing in today's lesson. So what happens is that, so one of the purposes of the hash function is to convert a string to an integer, which allows us to place the string in the hash table. But other than that, this hash function, guys, can be used to convert string to an integer for various other reasons. For like, a string is something which is very difficult to handle. So, but on the other hand, a integer is a flexible data type, and it's very easy to manipulate an integer and to perform a lot of calculations on an integer. So if someone asks you to choose between an integer data type and a string data type, an integer data type is the best way to, is a better way data type to work with. So if we have some means of converting a string to an integer, it helps us a lot. And this conversion from a string to an integer is a very important conversion, and it is widely used in several applications in real life and in competitive programming. Today we are going to be looking at some of the conversion techniques, and we will be looking at some of the places where we can apply that technique in competitive programming. The last point out here is that a good hash function is one that distributes the keys uniformly and causes as little collision as possible, which means that if I have a hash function, we saw in the first lesson that a good hash function is one which will take all my keys and it is going to distribute it among all the slots uniformly. At the same time, it is going to cause as little collision as possible. That is to say that ideally speaking, a hash function must be such that if we have two keys A and B, such that the hash value of them they have the equal hash value, then they must be equal. Or in other words, if you have two keys which are different, they will be providing you with different hash value. That is, the collision probability is very less. So this is the most ideal scenario, which means that there is absolutely no collision. Such kind of functions are very difficult to implement in practice. In practice, whatever function we use has somewhat or the other collisions. But as long as the probability of collision is less than 10 to the power minus 6, we consider the function to be a good function. Good hash function in general. All right, so without much further ado, let's get into the first topic for today. So the first topic for today is string hashing. So we are going to be looking at some way to take this string and convert it into an integer hash. Convert it into an integer hash value. So what we are going to do is that the first step is that we are going to assign an unique number to each character of the alphabet. By alphabet, we mean the distinct character set used. What do I mean by alphabet? Guys, alphabet doesn't refer to the alphabet as in like the English alphabet or the Latin alphabet. Alphabet in general means a set of characters which you are using in your system. For example, if the set of characters may be A to Z, 0 to 1, question mark, exclamation mark. So these are all the set of all distinct characters which you will be using in your system is known as alphabet. So the first, let's take an example to understand this string hashing. All right. So let's take an example. Let's say that I want to hash this string S, which is A, B, and D. And let's say that the alphabet I'm using, the alphabet set I'm using, consists of lowercase English characters. Lowercase English characters. So the first step will be to assign a unique number to each character of the alphabet. That is, I'm going to take each character from this set and I'm going to assign a unique number to it. All right. Okay, let's go take a next new slide. So step 1. Let's say that so what do I mean by assigning a unique character? It means that for each alphabet, each letter in the alphabet, I'm going to assign some character. It may be as simple as assigning integers, like you can assign A to 1, B to 2, C to 3, and maybe Z to 26. Or maybe you can use something like the ASCII characters. You can assign A to 97, B to a 98, and so on. Or you may be using some other integer sequence. This decision totally rests up to you. Whatever unique number set you want feel like to use, you can use it. This decision is totally up to you. Let's say that for this example I choose to use this set. All right. Okay, this is step 1. Let's see step 2. Step 2 says that we need to calculate the weight for each character present in the string. The weight of the ith character in the string is given by p to the power I, where p is some prime number and I is the index of the character in the string. So here we have another decision to make. We need to select some prime number. Okay, step 2. Let's say that for this example, for the purpose of this example, I am using the prime number 29. All right. So this is another decision you are free to make on your own. You can choose any prime number. Okay, and we need to assign weight to each character in the string. The string we are using is A, B, D. Okay, let's write the string. So we are using the string A, B, and D. These are the characters in my string. We have assigned the values. A has a value of 1, B has a value of 2, and D will have a value of 4 according to the unique number set we have used. And let's assign the weights to them. The weight is given by p raised to I, where I is the index of the character in the string. So the indices are, this is the 0 index, this is at 1, this is at 2. So the weight of the first index, the weight of A will be 29 to the power 0. The weight of B is going to be 29 to the power 1, and the weight of D is going to be 29 squared. So now let's calculate the hash value. If you calculate the hash value, it comes out to be 1 times 29 to the power 0 plus 2 times 29 to the power 1 plus 3 times 29 squared, giving us this value is 3423. So this is the hash value produced by this string. All right. So has everyone been able to follow up to this point? So this is the third step. We perform the third step. So has everyone been able to follow up to this point? If you have any question, feel free to post them, and if you have understood, just drop a thumbs up. Arunava is asking, why do we need to assign the weights? Okay, that's a good question. Why do I need these weights at all? Why do I need these weights? Let's say that I define a hash function. Let's say that I define some hash function. Okay, so you can define a hash function as sum of from I equal to 0 to n. Can we simply write a hash function as the sum of values? Yes. So let's define a hash function as value of I. All right. So this is what you're asking, right? So in this equation, we have used sum of weight times the value. But instead of weight, you're asking me why can't we simply write a value of I? Well, Arunava, yes, we certainly may use this hash function. This is capable of converting, this is capable of taking some string and converting it into some integer. So this is string, this is able to do that. But this is certainly a hash function. This can be used in practice, but except for the fact that if you remember closely in the beginning of this lecture, while doing the recap, we discussed one important point, and that is a good hash function is one which will cause as little collision as possible. So in case you are considering this as a hash function, let's say that you want to hash the value abd. It's going to be 1 plus 2 plus 4 as per the values we chose in the first step. So it's going to be 7. Now if you again consider the string bad, it's also going to be 2 plus 1 plus 4 equals 7. So you see here is a collision. As a matter of fact, if you perform any permutation of these characters, you will get a collision. So there will be a lot of collision if you just simply use this as your hash function. So this can be used as a hash function, but this will cause a lot of collision. So it's a very poor choice for a hash function. That is the reason why, that is the main reason why we assign a weight to each position, so that each position gets some importance. Is that clear? Good. Even as a matter of fact, guys, if you might have guessed it by now, like where did we get this motivation for this formula? Where did we get this motivation for this formula? If you take a look at this portion, hash equal to 1 into 29 to the power 0 plus 2 into 29 to the power 1 plus 3 into 29 squared, you might have guessed it where we got the inspiration for this. If you haven't, here is a small hint for you. This formula is very similar to the formula for converting a base n number to a decimal number. Like for example, if you have been provided with some octal number, let's say 137, you can convert it to a decimal using 7 times 8 to the power 0 plus 3 times 8 to the power 1 plus 1 times 8 square. So this is similar. This is quite similar. Here 8 is the base, which is n, and here we have chosen some prime number at random. Okay. As a matter of fact, if you choose this prime number to be around the same size of your alphabet size, then this hash function is going to be an excellent hash function. So is that clear to everyone? Just drop a thumbs up. Cool. Now let's proceed. So now that we know how to convert a string to a how to basically take a string and convert it into an integer, but this method is very good. This hash function is a great hash function actually. This is one of the best hash functions to use, and this hash function is used very frequently in competitive programming. But this hash function has a downside. There is a downside to this. And the downside is that this hash function, this hash value may grow beyond your integer range. That is to say that since you're multiplying each character, assigning a weight and multiplying it by prime and taking the power of some prime, once this string starts to grow, your value, let's say you have a string of length 10 to the power 5 characters. So if you calculate the hash value of this string, you will find that this value won't be fitting into your integer variable, which is a 2 to the power 32 or at most 2 to the power 64. It's not going to fit in this range. So the downside is that it's not going to fit in your integer data types. So what do we do is that we take our integer overflow correction. So how do we take this correction? We introduce this modulus factor out here. We choose another aim. So we choose another aim. This aim, which is also another prime number. So we are free to choose this prime number too. So we choose this aim and we just mod this entire value so that this value gets wrapped in the range of an integer. Now, as soon as we introduce this mod, guys, this hash function, the performance of this hash function is going to reduce. Why? Because there is a probability, now there is a definite probability of collision. if you remember from the very first lesson, we discussed about this hash function in great details. In the first class, we had discussed about this hash function. We said that if we have a hash function where we take a number and we divide it by a name, by some number m, and we take the remainder, this answer is always going to be in the range of 0 to m minus 1 from basic mathematics. This is what we get from basic mathematics. So there will be only m values. So from 0 to m minus 1 means there is only m possible values, hash values. Now if you are finding the hash of more than m strings, there's always going to be collision. It's same as saying that let's suppose that you have 5 bags and 6 balls. If you have 5 bags and 6 balls, so if you create 5 bags and you place the 6 balls in them, however you arrange the 6 balls, there is going to be a bag which has 2 balls. So it's sort of the same thing. Once you introduce a mod m, the value is going to be in this range. So if you are hashing more than m strings, there has to be at least one collision. So as soon as we introduce this mod m, the performance of this hash function is going to fall. This is not going to be that excellent hash function which we discussed. Obviously, if you increase this range, so as big, so if we increase this range, comma, the probability of collision will be greatly reduced. The bigger we have this range, the probability of collision is going to reduce further. And for Java or C++ or C, the languages like this, we have a maximum integral range of 2 to the power 64. So this is a great choice. This is one of the good choices for this aim value. So most competitive programmers use this value 2 to the power 64 to calculate the hash function, because the probability of collision is reduced. This is the maximum value of a long integer, long int, or a long in Java. Alright, has everyone been able to follow so far? Okay, now let's talk a little bit about why we are learning all of this. Why do I need to learn to write my own hash function? Why do I need to convert my string to an integer? What good can come from that? Let's take a motivation problem, guys. So here's a motivation problem for you. Let's say that you have been provided with a string A. And you have to perform Q queries on this. In each query, you will be provided with another string B, and you need to find the number of occurrences of B as a substring of A. So what you need to do is that you have been given a string A. This is the string A. This is the first line contains the string A. You have been given some string A, and the next line contains Q, which is the number of queries. This is Q, and each query contains another string B. So this is another string B, and you need to find the number of occurrences of B as a substring of A. So number of times this day occurs in this entire string. So here is one day out here, today ka day, and there is one day. So the answer is 2. The next string is gonna. Here is one occurrence of gonna, and here is another occurrence of gonna. So there is 2 occurrence of gonna out here. So this is the question, guys. So take a minute to read this question, and if you have any problem with if you have any doubt with the problem statement, just let me know. Okay, guys, let's proceed. Okay, so this is a very simple question, and I am sure some of you might have solved this question before. There are actually a couple of good solutions to this question, and those solution may be even simpler than the solution which I am going to discuss right now. But I'll stress on solving this question using whatever knowledge we have gained so far, so as to just be more fluent with whatever the concepts we have so that when we move to more complicated questions, we feel ease. All right, so let's get right to it. Let's say that I have been provided with some string. Let's take an example. let's take some example. Let's say that I have been provided with some string a, and this string is a r, b, r, and r. So this is some string a, and let's say that I have been provided with some string b, and this string b is r. Let's say that the length of this string is length of the string is an m, which is a 6, and the length of string b is a n. Let's take this to be n. Is a m, which is 3. Now I want to search this 3 characters over here. How do we need to do so? Let's talk about the most basic solution, the brute force approach. In the brute force approach, what we are going to do is that we are going to take every substring of length m from this string a, and we are going to check. Let's say that the first substring of length m is going to be this one, rbb. So we are going to take that string rbb, and we are going to compare it with our string b. The second substring is going to be this bbr out there, bbr. So it's bbr, and we are going to compare it with rrr. The next is going to be brr, and I'm going to compare it with rrr. And the last one is going to be this one, which is rrr, and I'm going to compare it with the string rrr. Okay, so how do we compare in brute force? So what do we do is that we check character by character. So we take the first character, and we take the first character, they match, so we move to the next character. They don't match, so this is obviously not one of the strings. Then we come over to the next pair. This character and this character doesn't match, so this is also rejected. This character doesn't match, this is rejected. This character and this character matches, this character and this character matches, this character and this character matches. So that we have a complete match out here, so this is one of the answers. So the answer here is going to be 1. So this is the brute force approach, guys. So how do we do this? We have to select every substring of length m from a, and we just need to compare. So in that case, this first one is going to consume a time of O of m. The second comparison is also going to consume a time of O of n. This is also going to consume a time of O of m, and this is also going to do the same. So the total time complexity is going to be O of n times m. This is the brute force complexity. Now I want to solve this using hashing. Just a brief reminder, guys. If we have two strings s and t, and if we have the hash, if assuming that there is no collision, if we have the hash of both the strings as same, then we can consider that the strings are equal. So if we find the hash of s, we find the hash of t, and we find that the hash of both the strings are the same, then we can conclude that the strings are equal. So I need to solve this using hashing. So how do I solve this using hashing? So one way would be to just hash this and just check the value. But still that is going to consume me an O of m time, because if we have to find the hash value, as we saw in the formula right over here, the formula is we have to pick each and every character, find its weight and find its value and multiply them. So in that case, we can pick each and every value and multiply them. So that is going to consume me an O of m time. So each of these comparison is still going to consume me an O of n time, giving us still giving us the time complexity of O of nm. So finding hash of these individual strings and just checking the integral values are equal or not is not a good approach, because it's no better than the brute force approach. We still end up with the same complexity. So can we do anything better than this? Thankfully, there is a very important property of this hash function. There is a very important property of this hash function which can reduce a lot of computation. And that property is that these things can roll. All right, let's just check how they roll. Let's say that you have been provided with some, let's say that, what do we do first? The first step was calculate. First, what we did in the beginning was we calculated the hash of the first m characters, right? That is, in this case, we calculated the hash of the first 3 characters over here, the first 3 characters. So we are calculating the hash of the first m characters. So let's do that. Hash of first m characters. and that is equal to s naught m characters of string s, of some string s is equal to s naught s0 plus s1 times p plus s2 times p squared, and so on till we reach s m minus 1, which is multiplied with the power of p minus 1. After we find the hash of the first m characters, we compare it with the string b, we compare it with the string. Let's say that it's not equal, so we move to the next m characters, which is bbr. We move to this next m characters. All right, so next we do is that hash of the next m characters, hash of next m characters string s is equal to, it's going to start from the s1 and then it's going to be s2 times p plus s3 times p squared all the way up till s of m p to the power m minus 1. So basically what happens is that in this first window of m characters we had from s0 till sm minus 1, and in the second window we have characters from s1 till s of m. So this is the difference between the two. So we are adding 1 to each. This becomes 1, 1 becomes 2, 2 becomes 3, m minus 1 becomes m. So let's say that this value is h1. What I want to do is that I want to take this value h1 and use it to calculate this value. Right? Let's say that this value is h2. So I want to use this h1 to calculate this value h2. So first thing is that this term is not there in h2. This s0 is not there in h2. So let's just subtract that. So let's take h1 and let's subtract the s0. So we are left with, if we subtract the s0, then we are left with s1 p plus s2 p squared plus all the way up till sm minus 1 p of m minus 1. Alright, so now let's take the p common from both sides and divide both sides with a p. If you divide both sides with a p, you get s1 plus s2 p all the way up till sm minus 1 p of m minus 2. Now this equation and this equation is almost similar, except the fact that we don't have this portion, we don't have this term. So let's add this term on both sides of this equation. So if I add this term on both sides of the equation, then I get an sm pm minus 1 equals to, now this our right hand side will be exactly equal to this h2, so this is h2. So that's about it. So this is how we can actually use this h1 to calculate the value of h2. Is this clear so far? Guys, have you been able to understand this? Just drop a thumbs up, and if you have any queries, just feel free to ask them. So let's proceed. Okay, thank you guys. Alright, so now we know how to calculate this value h2. That is, how can we calculate the hash of the next m characters, given that I know that the hash of the first m characters. If I have the h1, we can calculate the value of h2 using this equation. Okay, so let's add a new slide. Okay, so let's write the equation again. The equation is h1 minus s0 divided by p plus p raised to m minus 1 times s of m, I guess, p raised to m minus 1 times s of m is equals h2 equals to h2. So this is the equation. Now the hash value is actually, we have to make the integer correction, like integer overflow correction. So I have to take mod of m on both sides. If you take modulus m on both sides, so if I take a modulus m on this side, mod m, and I take a modulus m on this side, so what is going to happen is that h2 mod m is going to be h1 minus s naught times mmi of p plus minus 1 times s of m. This entire thing mod m. So what is mmi? Mmi stands for modular multiplicative inverse. Alright guys, so in case you guys haven't been able to follow how we got this modular multiplicative inverse from this division, feel free to just we have a session on we already had a session on new number theory and modular arithmetic on this platform. Just feel free to check out that video so you'll understand better. I'm not going to go into the details about modular arithmetic. So this is how it works. Okay, so so basically now what we did was that when we had h1, the first window, when we had this h1 value of h1, hash value of this one, from here to here, this step we can easily do it in O of 1 using the formula we just found out. Similarly, once we find this value, we can go from here to here using a O of 1. Similarly, from here to here, we can go using a O of 1. So each of this step, this first step may we have to calculate the hash value of the first m characters. There is no way to change this, but for the rest of the comparative pairs, we can just reduce them to O of 1. O of 1. That is to say that to calculate the hash value of the first one, this step is going to consume you a time of O of m, and after that it's going to take a time of O of 1, O of 1, O of 1. Alright, okay, so so if you find out the total complexity, it's going to be O of 1 plus it's going to be O of 1, O of m plus n, sorry. So this is going to be the time complexity. So we have successfully reduced the time complexity from O of mn down to O of m plus n. Have you guys been able to follow? If you guys have any problem, feel free to ask me, and otherwise just drop a thumbs up so that I know that you have understood before we proceed. Okay, chalo. Now that we have the solid understanding of what is going on, let's get into the code. Okay, let's get into the code for this question. Okay, so this is the question. Let's get into the code. Okay. Can you guys see my screen? Can you guys see my editor? Just drop a thumbs up. Okay. All right. Okay, let's start with the coding. Okay, so guys, before I proceed, this one thing I forgot to mention is that whatever we learned so far is a very famous algorithm, and that name of that algorithm is known as Rabin curve pattern searching algorithm. So it is used to search for a pattern in the text. It's used to search for a substring in the text using a rolling hash. So what we have is a hash function, and we are rolling the hash function, and this entire thing is known as a Rabin curve algorithm. Now let's get right to the implementation of this algorithm. All right, chalo. So let's we have a I have already written the boilerplate code for you guys. So we have taken the input A, we have taken the input queries, we have taken the query strings, and we are just passing the strings to the function. This is the string A and this is the string V. So we need to find the number of occurrences. We have to find the number of occurrences of B in A. So that's all we need to do. Okay, let's get right to it. Okay, so before we begin, we first have to decide on what are the various parameters which we are going to use for our hash function. What are the parameters? The first parameter is the values, deciding the values for each character in the alphabet. Second parameter would be deciding the value of P, and the third parameter would be deciding the value M. So for this code, let's say that I want to choose the parameters as such. Static int P, I want to choose the P to be 31. Let's take the M to be let's take this M to be 10 to the power 9 plus 9. Let's take this M to be 10 to the power 9 plus 9. All right, and for the values I'm going to just simply use the ASCII characters. Okay, all right. Okay, so now another optimization which we can do out here, and we will be doing, is just to pre-computing all the powers. Let's take some max number based on the constraint. Based on the constraint provided, we can just take some max limit. Max n static and chalo. Okay, so let's get to it. Okay, and we also need the prime inverse. All right, we also need the of so we also need the prime inverse, that is static int prime inverse, which is nothing but this number is nothing but the MMI of P, which I was talking about. So I'm not going to be calculating the MMI. So there is this great website which we can use. This is known as MMI online calculator. Okay, let's just paste this. Right, let's just paste this out here. Okay, so the integer I'm using is 31. I'm using a 31, and the modulus I'm using is 10 to the power 9. So 1 2 3 4 5 6 7 8 9, 10 to the power 9 plus 9. Let's calculate the modular multiplicative inverse. Okay, so this is my modular multiplicative inverse. Let's use this number. All right. Yeah, chalo. Okay, let's start. Let's get to it. Okay, so if we need to first calculate, first I'm going to calculate all the pre-compute. I'm going to pre-compute all powers of P. Right? Let's pre-compute all powers of P. So powers of 0 refers will be equal to 1. Okay, powers of I refers to the value of P raised to I. Okay, so now for the rest of the values, okay, let's take the length of the string, and n is equal to a dot length, and I is equal to 0, I equals to 1, I less than equal to minus 1. This is a dot length. So let's take this capital variables is equal to p dot length. So we are pre-computing all powers of I first. Once we are done with that, we will calculate the hash for the first window, first window of size m. As we say that we cannot avoid calculating for the first window, so we need to do that. For int I equals, for int I equals 0 and I less than m, I plus plus. Okay, so we will take two variables out here. Let's take two variables, long hash a, which will store the hash from the windows of string a, and hash b, we will store the hash from the windows of the string b. Hash a is going to be hash a plus, let's define the value function. We'll define the value version. Okay, so a dot char at I multiplied with powers of I mod m. Similarly, we can calculate the hash b equals to hash b plus value of b dot char at I times powers of I mod m. Let's define the value function. Right, for the value I'm just going to be taking in the character value. We are going to just take in the character and return the ASCII value. To do that, I just need to typecast it to the integer and return it. Alright, chalo. So once we have calculated for the first window, now we just need to roll and check the hash values. Alright, so let's keep the int count, the number of substring matches. This is going to contain our answers. So now let's start rolling. Okay, less than equals n minus m, I plus plus, if hash a equals hash b, if we have a similarity, then we just increase our count. If I is less than n minus m, then we just roll this hash. Now we roll this hash. So to roll the hash, we need to first subtract the first character, which is going to be char at I, multiply this entire thing by the prime inverse. We need to multiply this entire thing by the prime inverse. Yes, prime inverse, and do we need to multiply this entire thing with the prime inverse and do a modulus of m. Okay, and to this we need to add the last character. Okay, so here may be a negative sign. Let's add an m over here. Okay, so next we need to just add the last term, which is value of a dot char at I plus m multiplied with the powers of m minus 1 mod m. Yeah, I guess this. So this is the rolling. This portion is we are just rolling into next window, and this portion is just checking the hash. Okay, let's count, and then we return the count. I think that's about it. Let's just check this out. Okay, let's just move this. Right, chalo. Okay, let's take the example provided to us. Today is gonna be the day that they are gonna throw it. So this is the string input, and then we are going to take the number of queries input. The first query was a day, so it occurs twice. The second query was gonna. Let's see this. It also occurs twice. Okay, so that's about it, guys. Okay, so let me know if you have been able to follow it so far. Follow the code. Just take a minute to take a look at the code and tell me if you have any queries. Has everyone been able to follow? If you have any queries, just feel free to ask me. And if not, just send me a thumbs up so that I know that you guys are following. Cool. Chalo, let's move on to the next thing in our hands. Okay, so the next question, this is going to be a little bit more challenge. So you have been provided with a string, and this string is 0 indexed, and you have to perform Q queries on this string. In each string, in each query, you will be provided with some index L and some index R, and you have to output if the string from L to R is a palindrome. Let's take this example. Let's take this example. If I have this example A B B A C, and if I have been provided with this index 0 1 2 3 4 5, so 5, so this entire thing is a palindrome, so the output is going to be true. So this is the question. Just take a minute to read through the question and let me know if you can follow the question. If there is any doubt regarding the problem statement, let me know. Okay. All right, guys. So, any ideas how we can solve this? All right, guys. So let's get to the solution. Okay. So yeah. So what's a palindrome? Before beginning, let's discuss what's a palindrome. Like, it's a very simple question. A palindrome is something, if you take some string and if you reverse the string, it's going to be still the same. So if you take the reverse of the string, it's still the same. Something like ABA. If you reverse ABA, it's still ABA. It's the same. So this is something a palindrome is. Now, I want to introduce hashing into this question anyhow. So what I'm going to do is that we know that when two strings are equal, they have the same hash value, right, guys? So if S and S reverse are equal, we can easily say that the hash of S is going to be the same as hash of S reverse, assuming that there is no collision. Assuming that there is no collision. In the previous example also, we have assumed that there is no collision. Actually, we took the value of M for the previous question. We took the value of M, we took this value of M as around 10 to the power 9 plus 9. So the probability of collision is approximately, so the probability of collision was approximately 1 by M. It's approximately 1 by M, so it's approximately 10 to the power minus 9. So it's pretty low, so it's pretty acceptable, I think. Anyways, let's proceed. So if we take a string and we take its reverse, and if we have the hash value, so if we take a string and I find its reverse and then I find the hash value of both the strings and I compare the hash values, then I can say that if they are equal, we can say that yeah, it's a palindrome. So that's the core logic, guys. Now the most important thing to note is that calculating the hash value is going to take, like, in this case we don't have a fixed window that we can roll over. We don't have a fixed window over here. Right. So in the previous example, there was a fixed window. You could roll the window all over the screen, whatever you could fill, you could do whatever you could fill like. But in this case, you have been provided with this L and R. So this L and this R can be located anywhere in the string. So the size of the substring is not fixed. Since the size of this substring is not fixed, so to calculate this hash value, in the worst case, is going to take you O of n. If you have to travel, use a loop to travel this entire string to calculate the hash value, it's going to take you O of n. And so the total complexity is going to end up to be O of q times n, which is a very terrible complexity, to be honest. But fortunately, we still have another property of this hash function, and that property is going to help us here. The property is that we can actually compute the hash value of any substring. Once we compute the hash value of the entire string, we can compute the hash value of any substring in O of 1. You don't need to trust me, I'll show it to you. All right, let's get to it. Let's say that I define some function, and this function is hash I, which gives me the hash of the first I characters of a string S. Okay, so we have some string S, and this hash I will give me the hash of the first I character. It's just going to take the first I characters and it's going to compute the hash and give it to me. So we can talk about the boundary conditions, like hash of 0 is always going to be 0, because if I don't take any character, the hash value is obviously going to be 0. The hash of I can be written as obviously s of 0 plus s of 1 times p plus so on till s of I minus 1 times p minus 1. So we are taking the first I character, so it's going to be 0 to I minus 1, and this is going to be the hash value of the first I character. Now, as we said before, that my target is to calculate the hash value from of the normal string, and we are going to reverse the string and calculate the hash value again. So to do so, what we are going to do, instead of reversing the string, what we can do is that we can once calculate the hash in this direction, and once we can calculate the hash in this direction. What I mean to say is that I start calculating the hash by considering that my string is from this side to this side. That is, I take this as my S0 and I calculate some value. So in this direction, this is going to be hash from left to right, and I can calculate the hash from right to left too. So I start by considering that this character is my S0 and this character is my S1, and multiply this character with p0, p to the power 0, multiply this character with p to the power 1. So I can move and calculate hash in this direction. So I don't need to explicitly reverse my string, I just need to reverse my hash calculation. That is going to be enough to calculate the hash from right to left, right guys? So all I need to do is to calculate the hash from left to right and the hash from right to left, and then I need to just compare the two values. So let's see what is hash left to right. The hash left to right is going to be the hash from character L to character R. So the first character is going to be S of L, the second is going to be S of L times P, S of L plus 1 times P squared, and right up till S of R times, I'm sorry, I missed, this term is not there, I wrote the same time twice. S of R times P raised to the power of R minus L. Okay, so this is going to be the hash. So if you have a string, you take the substring L to R and you calculate the hash value is going to be something like this. You start from the Lth character and you end at the Rth character and you multiply it with primes. This is the first, so this is going to be P. This is not going to be P square. Just remove these terms completely. Yeah. So this is going to be P. Okay, so this is going to be S of L plus 1 times P. This is going to be L plus 2 times P square and so on. So this is going to be the hash of L to R. Now I want to somehow use this function. To calculate this value. Let's calculate. So the highest term in this function is S of R, and the lowest term in this function is S of L, right? So since the highest term is S of R, let's first calculate hash of R plus 1. Why R plus 1? I'm taking R plus 1 so that R plus 1 minus 1 is going to be R. So if I take R plus 1, this is going to be S of 0 plus S of 1 times P plus dot right up till S of R times P times R. Just I'm putting this value R plus 1 in this equation. If I replace every I with this R plus 1, it's going to be the same. Yeah. So now we have this term, but now if you look at this hash L plus R, it doesn't contain the terms from S0 to SL minus 1. So in this equation, we need to remove all terms from S0 to SL minus 1. We need to remove all of these terms, right? So to remove all of this term, let's calculate hash of L. If I calculate the hash of L, it's going to be S0 plus S1 times P plus right up till SL minus 1 times P to the power L minus 1. Right guys? Now let's subtract the two. So let's perform a subtraction operation between the two. If you subtract the two, it's going to be hash of R plus 1 minus hash of L. It's going to be S of L times P to the power L. S of L times P to the power L plus S of L plus 1 times P to the power L plus 1 right up to, what is the last term over here? The last term out here is S of R to the power P to the power R. So S of R P to the power R. So this is the last term. So we can take a P to the power L common from this side and just divide both sides by P to the power L. If we divide both sides by P to the power L, it's going to be hash of R plus 1 minus hash of L divided by P to the power L is going to be S of L plus S of L plus 1 P plus S of R to the power P to the power R minus L. Now if you look at this equation and this equation is exactly the same. So this value is equal to hash of L to R. So you can calculate the hash of any substring L to R using this formula, hash of R plus 1 minus hash of L divided by P to the power L. Is that clear to everyone? Just send me a thumbs up if you have understood things so far. Okay, let's proceed ahead. Okay, so this is the hash value from L to R. Now what about the hash value from R to L? How do we calculate that? Well, this is pretty similar. You might have guessed it by now. How can we calculate the hash value from right to left? So since similar to this function hash of I, we can create another function. We can create another function which is reverse hash of I. So we can create another function reverse hash of I, which calculates hash of last I characters. So once you calculate this and you try the similar logic, you just go through the flow of that similar logic, you're going to end up with something like this. Hash of R to L is going to be reverse hash n minus L. N is the size of the string, so it's n minus L minus reverse hash of n minus r minus 1 divided by, this entire thing is divided by p raised to the power of n minus r minus 1. Yeah, so this is going to be the hash from right to left. Alright guys, so have you guys been able to follow it so far? Then we can just quickly jump through the code. Cool. Now let's jump to the code, guys. I'll be sharing my screen. Just let me know if you can see my screen. Can you guys see my screen? Yeah, Priyank, this was whatever we discussed. It was very similar to the prefix sum. So instead of calculating the prefix sum, we just calculated the prefix hash, and we just subtracted it to find the hash of a particular substring. In the similar way, while finding the reverse hash, what we did was we calculated the prefix hash and suffix hashes, and we just subtracted. So can you guys see my screen? Can you guys see my editor now? Just let me know. Okay, chalo, let's jump to the code. Okay, as usual, I have the boilerplate code ready, and let's write the palindrome. Okay, so first we will declare all of those variables. Let's declare all of those variables. Right. So for this case, we have the maximum static. We have the static int max n to be equal to 2 times connect with 5. Let's say some variable. Okay, so now static long power as usual. So we are going to be declaring this stuffs again. The next thing to declare is the hash static long hash, which is going to be new long max n static long reverse hash new long max n. Let's take the prime to be 101. Let's take the m to be the same value, which is int 1 e9 plus 9. Okay, so let's Okay, so after taking the input, I'm going to call some init function. Let's pass the n string and the size of the string. This init function private static void init, it's going to take some string, it takes the length of the string, and it is going to do all the pre-computation work, pre-compute prime. So it first pre-computes all the primes, sorry, pre-computed powers, I'm sorry, so sorry, pre-compute all the powers. Next we want to pre-compute the hash, which is, let's pass in the string and the size of the string. We also want to pre-compute the reverse hash, let's pass in the string. All right, chalo. Now let's quickly pre-compute the powers, private static void pre-compute powers, and n. Okay, so powers of 0 is going to be 1, pretty similar to the last code. This section is pretty similar. Into I is equal to 1, I less than equals n, I plus plus, powers of I is equal to powers of I minus 1 times p mod m. Sorry, this variable is clear as powers. Okay, chalo. So the next thing is to pre-compute all the hashes with static void pre-compute all hash string s and n hash of 0 is going to be 0 as we discussed, we are not going to, and so it's int I equals 1, sorry, I less than equal to n I plus plus, hash of I equals to hash of I minus 1 plus s dot caret I minus 1 times powers of I, sorry, powers of I minus 1. This entire thing is modded with an m. Okay, so yeah, so that's the hash. Now let's calculate, let's pre-compute all the reverse hashes. Private static void reverse hash string s and n, let's take the reverse hash 0 equals 0 for int I is equal to 0, I less than equals n, I plus plus, reverse hash is equal to I is to reverse hash I minus 1. I'm sorry, the reverse hash, so this is going to be, we need to take in two variables. Let's take in two variables, j equals n minus 1, so we are going to calculate from the back, so greater than equal to 0, j minus minus reverse hash equals to this into s dot char at j times powers of I minus 1. So this modded with an m. Okay, seems okay. Yeah, so we have computed, okay, so this is pre-compute reverse hash, I'm sorry, so this is pre-compute reverse hash, variable name is, yeah. So now that we are done, we just need to calculate the two values, the two hash values out here. So let's take in the two hash values, long hash from left to right. Let's find the length of the string. Okay, let's find the length of the string, and n equals s dot length long is going to be hash from r plus 1 minus hash of L. So I'm going to multiply. So in the theory we discussed, it was something like of the sort like for hash LR was something like we had some numerator and it was divided with a power of p to the power L, and for hash RL we had some numerator and it was divided by the power of n minus r minus 1, right? N minus r minus 1. So this was divided. So instead of doing this division, what I'm going to do is that I'm going to be multiplying this one by this value, and I'm going to do a cross multiplication. Basically I'm going to multiply this with this and this with this. So powers of n minus r minus 1. Now let's do a mod m, and long hash right to left is going to be hash, reverse hash. This is going to be the reverse hash from n minus L minus reverse hash n minus r minus 1 times powers of L and modded with an m. So it's n minus L. Okay, so now we just have to check whether these two values are same or not. If these are same, then it's a palindrome, otherwise it's not a palindrome. This should hopefully work. Let's try this out, guys. Let's try this out. All right, let's take some input AA, BB, AA, C, I guess. Okay, let's take a query from this. Okay, what's a palindrome? 1 2 0 1 2 3 4 5 5. So 0 to 5. Yeah, true. Okay, let's try one more. Okay, so 0 to 6, which is a false. Alright guys, that's about it. So have you guys been able to follow the code? Great. Okay guys, so this was a very interesting question in which we saw how we could have used some concept which we learned in just the last class, which was the concept of prefix sum. We just reused that concept to calculate some prefix hash, and from that prefix hash we calculated the values of any substring in O of 1 query. So this function now can give us a query in O of 1. All right guys, so now so before we proceed, I just wanted to talk to you guys about one thing, and that was that we have a batch starting in 22nd December, guys. If you guys would like to join our intermediate batch, we have a very structured learning. We have very highly competent instructors who will be able to guide you. It is a complete batch structure. You will have an entire lesson plan, and you will be able to pair up with your favorite instructor and learn your coding. So I just wanted to give you a little gist about that. So this are some of the things. You'll have a live interactive class. You will get doubt support. You can get practice problems which are present in our own website, CodeChef. So this is our topic-wise batch structure, which we will be following. It's a 52-week course in which we will be covering right from the beginning, from sorting to right at the end of ICPC regionals and world final problem solving, guys. So we have some of the top educators with us who are working in these premium batches. So one of the batches will start on the 22nd December. So guys, just feel free to join that batch to learn more and have a much more structured learning. All right guys, okay, so now let's move on to the next question and the final question for today. Okay, stop sharing. Yeah, so can you guys see my screen now? So I'll be sending you the link to this question. So so this is a link to the question. Okay, so let's try this out. So this is a question from lunchtime. Let's this has a similar concept. Let's take a look at this question, guys. So what we have been given in this question is that you are given a string s, and a cyclic shift of s is a string formed by moving a number of characters from the beginning of the string to the end. Formally, for an integer k, the kth cyclic shift is a string r with length n such that r of I is equal to s of I plus k. R of I equals s of n minus I minus n plus k. A string is palindrome if it is equal to its own reverse. Calculate the number of palindromic cyclic shifts of this string. Alright, so I'll share my screen with you guys so that you can read directly from my screen. Okay. Can you see my screen, guys? Just drop a thumbs up. Good. Alright. So you have been given some string, and we have to perform a cyclic shift on the string. So I'm going to be giving a gist of what do they mean by cyclic shift. It's basically rotation. Are you guys aware of rotation? What a rotation of a string? What is a rotation in the concepts of strings? Okay, Arunaba knows what is the concept of rotation in string. So basically, rotation is a very simple thing, guy. So it's something like this. Rotations of a string. It means that, for example, let's take the example given to us in this question. The question was that it is AABB. We have been provided with some string AABB. So the rotations of this string is that I'm going to pick this character A. I'm going to pick this character A, and I'm going to place it in the end. Alright, so if I pick this character A and place it at the end, it's going to give me this string. So this is one rotation of the string. So this is one rotation of the string. Alright, again, so this is one rotation of the string. Again, you can take this again you can take this A and place it in at the end. So you will get another rotation of the string. We can take this B and place it at the end again. So you'll get another rotation of this string. So this is also known as a cyclic shift or a rotation. Cyclic shift or a rotation. Sorry, cyclic shift or a rotation of a script. So have you guys understood what do we mean by rotation? Just drop a quick thumbs up if you have been able to understand what rotation is all about. Great. So what we have is we are taking the first character and we are placing it in the end. We are taking again taking the first character and we are placing it in the end. We are again taking the first character and placing in the end. So only we shift the first character. Okay. So we take the first character and place it in the end. So this is a cyclic shift. So the question basically demands us that we have been given a string, and of all the cyclic shifts, you have to say which of the number of cyclic shifts which are actually a palindrome. So if you consider this case, we have 4 cyclic shifts. Okay, so if you cycle this back again, no, sorry, we have a b b, yeah. So we get back this initial string. So we have basically 4 unique cyclic shift. We have using 4 unique cyclic shifts. So out of these 4 cyclic shifts, you have to let me know how many are palindromes. How many of them are palindromes? So this one is a palindrome and this one is a palindrome. So the answer is 2. The answer must be 2. Let's just check it out. The answer is 2 or not. Yep, the answer is 2. Yeah, that's what I was talking about. So if I perform all the cyclic shifts, there are only 2 palindromes. So basically, this question basically asks us that you have been given a string, you have to perform all the cyclic shifts in this string, and you have to let me know how many of those are palindromes. So now guys, if you take a look at this, if you take a look at this, let's say that you have a string S. The string provided to me is AABB, right? So this is a very interesting property of rotation of an string. So there is a very interesting property is that if you take a string S and you concatenate to it itself. So in this case, if S is equal to AABB and you concatenate to it itself, then it's going to be AABB, AABB. So once you have a concatenated string and you take any n-sized window, take any n-sized window. So you take any n-sized window. If you take any n-sized window, you will find that it's a rotation of this string. So if you list all the rotations, it's AABB, it's ABBA, it's BBAA, it's BBAA, it's BAAB. So these are the 4 rotations. Now you take any randomly, you can choose any n size. For here n is equal to 4, obviously. So you take any, let's say that I choose this 4 sized. So this is a rotation of this string. You take any 4 size, so let's take this BAAB. You'll find that this is a rotation of the string. So any n-sized window will contain a rotation of the string. Okay, so guys, so basically now I can say that instead of finding all the rotations, I can just take the string and I can concatenate the string to itself. So once I concatenate the string to itself, now my question is in this string S plus S, find the number of number of palindromic n-sized windows. Is this question clear? Is this alternative question clear to everyone? Just drop a thumbs up. Great. So we have been provided with a string, and instead of finding all the rotations of the string, we concatenate to itself, and then what we do is that we find the number of palindromic n-sized windows in that string. To do so, so what we do is that so let's get right to the code. Okay, so let's just get right to the code and see what can be done out here. Right, chalo, share screen. Okay, share. Can you guys see my screen now? Cool. Chalo. Okay, so public static void main string args. Okay, so we need to take all the inputs first. Okay, chalo. So the inputs are going to be buffered reader br is equal to new buffered reader new input string reader. Yes, Priyank, this is a very great observation. This actually is very similar to the previous one. That is why I have chosen this question. And yes, you have cracked the logic. In each of the n queries, we just need to compute everything, just like in the previous question. And in this question, all we need to do is just take every n-sized windows and just use that prefix concept and the suffix concept which we have developed and check whether it's a palindrome or not in O of 1, right? Let's just go through the code. Yeah. So we'll take the number of integer dot parse and peer dot readline while t minus greater than 0. So we are going to solve this question. So print ln solve and solve this heading on the string. Let's say let's solve this question. So private. So let's copy the logic from the previous code. Just let's copy all of this. We are going to need all of this. So yeah, let's copy all of this logic to here, and we need these two. Okay, chalo, we need these, all of these. Let's copy, let's paste it out here. Let's let's increase this boundary, maxim, everything is alright. Let's take a smaller prime number. Okay, so yeah, now let's write this solve function. Private static int solve string s, right, and n is equal to s dot length, sorry, s dot length, s plus equals s. We concatenate it with itself, we init this entire string, comma s dot length. Yep, so that's init. Once we have initted the string, now we need to count all, so this variable is going to be counting. Now let's take all variables, let's check whether this is a palindrome or not. Palindrome, if this is a palindrome or not, so we will take the string and we are going to check whether this window is a palindrome or not. Let's I plus n minus 1. If this is true, then we count plus plus, and let's return the count. Okay, okay, this should work. Let's just check it out once. Okay, let's see if this works or not. Right. So this is the sample. Yep, for palindrome. Let's see 2. Okay, yeah, I think this should work. Let's just try it out. Submit. Sorry, this is not going to be a public class. Submit. Public class. Wrong answer. Let's find out what's going on. Okay, so this is the 3. Let's check the limits. Let's check the limits. It's 10 to the power 5. Yep. So yeah, so one, two, four, So guys, we are running out of time. I'm having a little difficulty debugging. This is the accepted code for it. There must be some edge case or something I'm missing out. Just take a look at this code. Uh, it's pretty much the same thing which I've done there. I must be missing out some modulus or something. And since we are running out of time, I won't be able to debug it on time on. So just take a look at this code. So it's the same thing what we were doing. We just had the entire code from the previous section. We are pre-computing the powers, we are pre-computing the hash, pre-computing the reverse hash, and checking the palindrome as discussed. And so what we are doing is that we are taking the string, we are just concatenating it to itself, and then we are just checking every window from I to I plus n minus 1, I plus n minus 1, and just checking if it's palindrome. I'm just counting it. Okay, so is this code clear to everyone? Just drop a thumbs up. Okay, so guys, that's it for today. Thanks for joining in. Hope you have learned something new in this micro course. uh, so that's all for this micro course. We will be ending the class now, and hope see you soon in the next one. Bye guys.